Hi guys, how's it going? So today actually I want to talk about why you should avoid loops some point. So especially from like data science perspective, whereby I think there could be a scenario where let's say you have a table like so, and you have a column, maybe something like an amount, right? So what you want to do is that you want to multiply each amount in the row maybe by text, right? But you want to multiply it if in a specific country, right? So one way you can go about this, you can say, okay, cool, I'm just gonna go with a for loop, right? So you're gonna say for row in this table, right? Then you can say something like if row dot country equals to something, maybe a specific country here. Then what you want to do is that you want to take a row amount and you want to multiply it by text, right? However, I think it's very important that you stick to libraries such as Pandas, you stick to NumPy, you stick to Touch, mainly because these libraries have been optimized to work with vectors, and I think some of them have been written with C, and I think it's called Python. So they're quite very fast to work with. So using Python for loops can really slow you down. So I'm just going to walk you through some of the examples that we have here. So what you're thinking here is that I have created this data set. You can think of it as like it has 100,000 rows. It has two columns. And the point here is that I'm starting with this experimentation whereby I'm actually going to try to override a specific value at a specific index. So what I do is that I'm going to square this element at this index and at this column, and I'm going to do the same for the second column by taking the value at this column and multiplying it by itself, and actually counting how long does this operation take for 100,000 rows. And we can see that I've already run this because it was going to take some while, so I run it in advance so that I don't have to keep you waiting. But we can see that it takes 38.7 seconds. It's quite long. And the key operation that we're using here is that we're saying df.index. So this index gave us an index of the table. So we're using that to access a specific element at the specific column. So this is not efficient at all. But it's not bad compared to eta rows. So eta rows, we can see that it's now number one, it's 45 seconds. So what I do is that I use this eta row for me to get an index and for me to get a row. So I can be able to use this to be able to access a specific column. But in this case, I want you to look at this very carefully. You can see that I'm taking the data frame and I'm taking this is how you index with pandas. So you pass in an index, you pass in a column, and I'm not necessarily using this row to access the column. So this amounts to 45 seconds. So it's also bad. So you should avoid such things. So how can we improve this? So we're gonna scroll down. What we can do is that we can leverage the row. So with this row, we can be able to access a specific column, right? And this row here, from either row, we can actually use it to access, and we can square that element. We're still doing the same thing. Nothing has changed. It's just that this time we're using the row instead of like using the df.log. And we can see that actually this reduces our time from 45 seconds to 17 seconds, right? It's quite an improvement. So, but still, I still don't like for loops, right? So let's look at etuples. So there is a function called etuples, so it's different from iteros, and we can see that it's quite better. It gets us to 12.1 seconds, and we're doing the same thing, taking the row and specific column, squaring up and assigning it to this at this element, but still not efficient, right? So now we're using NumPy, but we're using NumPy in a for loop fashion, right? So what I'm doing is that I'm taking the df and I'm converting into NumPy, right? Then I'm accessing the row and index, and I'm doing the same thing. Still not bad. It gets us to 11 seconds. So now I added the dictionary because the dictionary gives us a constant lookup. So I thought it would not be a bad idea to add it also to the comparison, because to get a key from a dictionary is O of 1. So what I did here was to look through a dictionary and access a specific column and square it up. It gives us 11 seconds. So still not better than NumPy though. But here we're not using NumPy in a clever way. So we still put it within a Python loop. So we're going to see how we can improve that. So look at this, guys. So now you can see that I'm leveraging, I'm doing everything on a table format. So I'm staying on the Pandas data frame to do all of these multiplications, and this essentially reduces our time to milliseconds. Like it's so fast, like it's instant, right? So you can see how slow this thing is. You can literally see, and I'll show you the overall time and the difference of how fast this thing is. But here I'm leveraging Pandas, and this is, I'll actually get into why some of the data scientists might actually want to work with for loops at some point. I'll get into that. But you can see that doing it this way, taking a data frame and doing everything from a vector perspective, it's very fast. And you can also do the same thing like this with NumPy, and you're still gonna get a very, 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 very better performance. Overall, taking vector operations are over like 4,000 faster than for loops, like 4,000x faster than for loop operations. So that's quite of a speed, right? So I've worked with PySpark, and one of the reasons I observe is that sometimes what happen and what lead to like for loops is that sometimes what happen is that you have multiple columns, right? Maybe this is like a gender, right? And what happen is that someone want to write like multiple for loops, multiple if-else statement, right? And this could be tedious doing it on a data. It's still possible to do it on a data frame level, but some people, they feel like, okay, I have multiple like conditions and I have to update a specific value based on multiple conditions. And to do it on a data frame level, then they feel like, okay, I'm just going to use a loop. So with PySpark, you can leverage things such as with column. There's so many ways you can go about it. Like with column actually allows you to do all of those operations, and you can add these conditions, and you add those conditions on them still on the table level. You don't have to go to the for loop. And with Pandas, I think you can also do it. You can do something similar to that. So yeah, I think that's that, guys, and I thought maybe this might be valuable to some of you. I'll share the notebook and you guys can reference it. Thanks. Bye.